I have many existential crises every single day. And one of my favorite things to do is to bring people into my existential crises by asking them big questions about the universe. Today, I'm going to bring you into my existential crises by asking you a big question. What is the universe made of? Unlike some of my other crises, I think I can actually answer this question by looking at the Beneski Museum's diverse collection of meteorites. One of the Beneski Museum's most famous collectors, Charles Upham Shepard, has a very well-known collection of over 25,000 minerals. But did you know he also had the fifth largest collection of meteorites for his time? Although those meteorites were given to Arizona State University in the 1970s, we still have a few meteorites here today. And our collection includes all three major types of meteorites. So that's iron, stony iron, and stony. To start, we're going to explore stony iron meteorites. Stony iron meteorites are made up of equal parts metallic and silicate materials. And there are two subtypes of stony iron meteorites, pallasites and Mesociderate meteorites. Here we have a pallasite stony iron meteorite, which was found in 1931 in Saskatchewan, Canada by H.H. Nininger. Pallasite meteorites were formed by melted asteroids, and they have something called olivine crystals in them, which are made of magnesium iron silicate. These crystals either appear as one crystal or clusters of crystal, always embedded by metal. Scientists believe that pallasite meteorites could possibly represent the boundary between an iron core and a silicate olivine-rich mantle, which could provide more information on formations of planets like Earth that also have iron cores and silicate olivine-rich mantles. However, other scientists disagree. They say that there are too few olivine-rich meteorites in the asteroid belt and too many pallasite meteorites found for this theory to be valid. So, more research needs to be done before any definitive answers can be found about what pallasite meteorites tell us about the universe. The next type of stony iron meteorites are Mesociderate meteorites. And an example of this is the Estherville meteorite. And these are pieces of the large Estherville meteorite that fell on May 10, 1879 in Estherville, Iowa. The Estherville meteorite is thought to actually be the biggest meteorite to ever touch down in Northern America. It is over 455 pounds. Mesociderate meteorites are thought to have been formed when two asteroids collided at the universe's creation, and the metallic and silicate materials mixed together. Mesociderate meteorites provide scientists with information about how the solar system formed and its history, and additionally, it provides them with information about the formation of iron cores. The third main type of meteorites are stony meteorites, which are mostly made up of silicate materials, and they have two main categories, chondrites and achondrites. Here, we have an ordinary chondrite meteorite entitled Kelly, which was found in 1937 in Logan County, Colorado by H.H. Nininger. Wow, that guy must have really liked meteorites. Now, chondrite meteorites are thought to be made of some of the oldest unchanged materials in the universe. The materials they are made up of have been unchanged for 4.5 billion years. This means that they have never been through physical or chemical changes, which means that they're considered undifferentiated. Chondrite meteorites are made up of silicate droplets and granules of sulfides and iron nickel. Because they are made up of the materials of the solar system's founding and have been unchanged since then, chondrite meteorites provide scientists with information about how the solar system was formed. Next, we have the other type of stony meteorite, achondrite meteorites. This achondrite meteorite fell on July 6, 1924 in Weld County, Colorado. And, of course, it was also found by H.H. Nininger. Unlike chondrite meteorites, achondrites are differentiated, which means they did go through chemical and physical changes. In the case of achondrite meteorites, these chemicals and physical changes come in the form of igneous differentiation, which means that they were melted into magma at some point and solidified to form concentric layers. Rocky planets like Earth also have concentric layers, so scientists think that by studying achondrite meteorites, they can learn a bit more about how the internal structure of planets like Earth formed. Next, we're going to take a look at some iron meteorites. Specifically, this iron meteorite right here, the Mohannis meteorite found in 1938 in Ward County, Texas by H.H. Nininger. Iron meteorites like this one are theorized to have formed when planetary cores had intense collisions during the solar system's infancy. During these collisions, the materials liquefied and then re-solidified, causing them to go through chemical and physical changes. This means that iron meteorites are differentiated. When the iron meteorites went through these chemical and physical changes, the dense iron sunk to the center and solidified and became an iron core, surrounded by layers and a silicate mantle and crust. Because terrestrial planets like Earth also have iron cores and silicate mantles and crusts, by doing research on how iron meteorites formed their iron cores, planetary scientists believe they can come to a further understanding of how planets like Earth formed. In fact, researchers at Johns Hopkins University are attempting to answer this very question by studying iron meteorites right now. Specifically, they wanted to know why iron meteorites tend to have a high percentage of heavy iron in their cores. Heavy iron is iron that has a higher number of neutrons than standard iron. To investigate this, they melted down materials just like in the solar system's infancy and then watched them re-solidify. They found that when the dense iron sunk to the center and crystallized to become an iron core, it became heavier iron with the higher number of neutrons. So, I guess my existential crisis is solved. I now know what the universe is made of. See you later. Oh, wait, what's that? The iron only accounts for 60% of a planetary body and meteorite's core. What's the other 40%? I guess I need to go do more research. Okay, I just finished up my research. It turns out scientists don't really know what the other 40% of planetary and meteorites' cores are made of. They're still doing research on it. I guess that's the thing about science. It's basically a bunch of theories that are based on the best evidence that scientists have at the time, which means that it's always changing. While I may not have solved my existential crises of what the universe is made of today, I now know what science is made of. A bunch of ever-evolving theories that are based on the best evidence that is available at the time of the theory's creation.